A Cutie Integral. So I found this integral like really beautiful in terms of the solution, in terms of how it appears, and how it's designed, everything. And so I named it Cutie. And regarding solution process, it took me just a few minutes, or let's say 5-6 minutes, to find out how we can actually solve this. Or you can also do it in less than that as well. It's not that tough. But let me show you like how did I solve. So here, what I first noticed is if you make a substitution, let's say y equals to 1 by x, which is basically how one can be obtained from other, like 1 by x. Yeah, and this denominator also remain unchanged because this x will go in numerator. Again, there will be 1 by x square. So basically, x will be conserved over here. And now, regarding the limits, this will be 1 by a. This will be 1 by b, but these are not the concept. Yeah, these are not same again. That's why I thought of multiplying this by ab now. And after multiplying by ab and making substitution y equals ab by x, everything seemed to work now, and yeah, it was then solved. Let's see how. If we make the substitution ab by x, this over here becomes b, this over here becomes a. Yeah. Now this is e to the power ab by x, so that's now b by x. Yeah, ab by ax is now b by x minus now ab by x. b cancels out, so x by a, e to the power x by a by x dx. Now you see, not really x, So over here also there is 1 by x. Sorry. Here also it's 1 by x, and then minus 1 by x squared dx. The minus sign now can be used to invert the integral. That's why it goes from a to b. E to the power bx, sorry, not bx, b by x minus e to the power x by a by x dx. Yeah. Now these two are actually the same integral, yeah, because I have just made use substitution and nothing else. Yeah, and I should basically write over here y, but it doesn't matter whatever the variables. That's why I wrote x again. Now if I add these two integrals, I should get 2i. Yeah, and 2i is actually integral from a to b of. Now if I add these, basically they cancel each other out, and that's why I have 0 dx. Yeah. And so this is c a to b, and this is c minus c, that is 0. So since 2i equals to 0, I should also be equal to 0. And since it seemed pretty complex, like we can just also guess that answer would be 0. My first thought actually was to use Laplace transform because there are similar kind of integrals, like let's say if it was e to the power minus ax minus e to the power minus bx by x. If it's going from 0 to infinity, in this case we can use Laplace, but also the limits are not from 0 to infinity. Basically we could have made it in the following way: s plus a minus 1 by s plus b, then ds. We could have done it this way. So I thought of that as well, but that didn't work, and then maybe some new substitutions, and this worked. Yeah, so that was how I deal. And let me know how did you find this integral. It was interesting or not in the comment section. Thanks for watching. Look forward to seeing you in the upcoming videos too.